is probably the most difficult task in the this week's assignments. And if you click on the Google Sheet that is created for you, you're going to have directions on how to put in exponents. And then you want to go down to the tab below that says varying charge and varying distance in order to input your information. So first, I'm going to walk you through a couple of the initial entries, and then you should be able to do the rest on your own. But if I were to just keep everything the same here in my simulation, okay, so I've got a -4 microcoulomb charge for charge 1. And when it's microcoulombs, that means that it's a very, very small number. It's times 10 to the -6 coulomb. So anytime you want to put an exponent in, for the first charge, I am going to type in -4, and then times 10 is always the E button. And then if it's the -6 power, you're going to plug in -6. So this first charge stays the same because it's telling you to change one charge and not the first charge. So we're going to change charge 2. The distance, it says the distance is 1, so I want to check the distance here. I want to check from mid-dot to mid-dot, and that's 1, 2, 3 centimeters. I'm going to convert that to meters. So I'm going to put that in as 0.03 meters, and then that is going to stay the same as well. I'm only changing the charge, and then we're going to write down the corresponding force. So from there, I want to take charge 2. I'm going to keep the initial charge 2 the way it is, 8 microcoulombs, and that gives me a charge of 320 newtons. I'm just going to round it up. So I'm going to plug in 8e to the -6 power, because microcoulombs is always -6, and then I had 320 newtons of force. So that changed a lot of stuff here in my diagram. Then I want to do 7 other charges and see how that changes my diagram here. So I'm going to move this maybe to -1. Let's try -1. That gives me a charge of 39 or 40 if I round it up. So -1e to the -6, and then I get, what was it, 40? Let me check it again. 39.9, which is 40. So these dots are really close together. As you plug in more values, they're going to start to spread out along your graph into some sort of shape. So initially you had a linear graph like this. You might see something similar, you might see something curved, but what I want you to do in your worksheet is once you plug in your 6 other points with the force associated with it, I want you to look at the shape and talk about that in this question. So provide a screenshot and write a short summary of what is happening. So if it's decreasing as your charge decreases or increases as the charge increases, or if it's opposite, or if there's sort of a curved shape to it, you want to talk about that relationship. When you vary distance, it's the same sort of thing. You're going to plug in your charge 1 and charge 2 and keep those the same. And then you're going to move your distance, either, start with a distance of, let's say 2, and then move it further and further and further, and then write down the corresponding force that goes with that.